be seeing an optimized way to solve the problem jump game. Now, before doing that, let's quickly revise what is this problem all about. So, in this problem, we are basically given an array and we will be starting at the zeroth position. So, from this position, we could make maximum number of two jumps, either one or either two, because the element that is present in this position is 2. So similarly, from this position, we could make three jumps because the maximum jump we could make is 3 because the element here is 3. So in the last lecture, we have seen how we could use DP to solve this problem, and that is not a very optimized solution. So how we could furthermore optimize? So let's try to think about it. Now, basically, we have to reach this position, right? So instead of starting from 2, we can start here. Okay. Now let's maintain a pointer over here. Okay. Suppose this pointer is P. Now we have to reach till this pointer from here. And we will be maintaining another pointer that will be just behind that. Let's call this as IDX. We already know the base cases that if the length of the array is 1, then we could always reach the end. And if the length of the array is not 1 and the first element is 0, then we could never reach the end. So these are the two base cases. Okay, now let's come back and let's try to see. Now let's try to see whether we could reach the last position from here. Okay, so how could we find that out? If idx plus what is idx in this case? 0, 1, 2, 3. That is 3. 3 plus. And what is the element present in this position? That will be suppose array of idx. That will be 1. And if this is greater than or equal to this p and the value of p here is 4. If this is greater than or equal to p, in this case that is 4, that means we could reach here. Okay, so now what we have to do is we have to decrement the pole. Now let's see, we decrement it to idx. Now from as we could reach the end from idx, then we have to see whether we could reach the idx or not. So in that case, what will happen is we are basically checking now whether we could reach the IDX. So our new pole will be shifted to IDX. Now let's see we could reach the IDX or not. Okay, we could reach the IDX from here. So we will shift the pole again to this position and we will be checking from here. So we could also reach this position, then we will be again shifting the pole and we will be doing the similar thing. If we are doing the similar thing again and again, that means we will be using a loop. So in this case, we are only required to use one loop. And if our pole reaches to the zeroth index, now hope I have made that clear because we are moving our pole first here, then here, and at the end we are moving it to here because we could reach this position. So if we could reach the zeroth position, that means we could reach the end position also because we are starting from the end. So what if the array is something different? Let's suppose our array is this 1, 4, 0, 0, 0 and 1. Now let's see what happens in this case. Let's dry run quickly. This is the pole. And what is the current position? 0, 1, 2, 3, 4, 5. Okay, this is 5. Now we will be at this position in the starting. Let's suppose this is our IDX. Can we reach here? No, because 4 plus 0 is less than 5. So we cannot reach here. So we will not be shifting our pole, but we will be decrementing our IDX. Now our next IDX is here. Can we reach here? No. Then we will be again decrementing our IDX and our pole is intact at position 5. Can we reach from here? No again. Then we will again decrementing our IDX. Now in this case, can we reach to the end? Yes, we can because 4 plus 1 is equal to P, that is 5. So we could reach the end from this position. Now, what we have to do is we have to check whether we could reach this position or not. Now, let's shift our pole to this position, and that will be our IDX. And we will be just decrementing our IDX again. Okay, now we are at this position. Can we reach this? Okay, we can reach this, so we will be shifting our pole again. Now pole is here. And as we cannot go further back, we will be breaking out of our loop. So now we will be checking whether our pole value is 0. In this case, yes, it is 0 and therefore we could reach the end. Now I know this is quite messy, but let's code that up and I'll guarantee you this will be really super clear to you guys. Now let's code this up real quick. This is the function that is given to us. Now let's quickly write the base cases. Now if the length of the array is 1, then we don't care what is the first element that is present, we will be always returning true. Okay, this is clear. Now let's see that now we know that length of the array is greater than 1 in any case. Now if we are given a 0 at the 0th position, that means we cannot make any jumps. In that case, we will be always returning false. Okay, these are the base cases and that are very clear to us. Okay, now what we have to do is we have to maintain a pole. Okay, now where we were starting at the last position. So let's maintain a pole. Let's see pole, and we will be starting at the last position. That will be this one. Okay, now we were also maintaining an IDX. And what was the IDX? It was starting just before the pole, means the last position, than the pole. That means our IDX will start from pole minus 1. Okay, now what we have to do? We have to loop. Okay, now as we are starting at the last position, we have to reach till the first position. That will be the 0th one. So if at any point of time we fall behind 0, that means we have to break out of the loop. So what will be the condition? The condition will be if IDX should always be greater than or equal to 0. If it is less than 0, just break out of the loop. That's what we are doing from here. Now let's check. Can we reach the pole from the IDX or not? How do we check that? IDX plus nums of IDX. This should always be greater than or equal to pole. Okay, if this is greater than or equal to pole, what we were doing is we have to shift our pole to IDX. Okay, let's do that. This is how we shift. And what we have to do, then we have to decrement the IDX. Okay, fine, we will decrement it. Now, what if this condition is not satisfied? That time we have to check for the rest of the element. That is the elements which are behind the IDX. How do we do that? We will just decrement it. Okay, and that's it. Now just we have to check a single condition. What was that? If the pole has reached the 0th position, that means we could reach the end. Now we will just return pole double is equal to 0. Basically, this is a syntactic sugar for writing if pole is 0, then written true, or pole is not equals to 0, then written false. Okay, now let's quickly check whether our solution works or not. And yeah, actually it works for the base cases. Now let's submit. And Come on. Yeah, it is working. As you can see, this is quite efficient solution. And yes, if you find this video helpful, please give it a like. It really helps the channel a lot. Thank you.